This is another practice problem for constant acceleration. The question is, what is the acceleration of the objects in the graph? Now, in a question like this, we don't have to write our three equations of kinematics because we're not going to use them. We're just going to read the graph. So this is a velocity versus time graph. So we have velocity on the y-axis, time on the x-axis, okay? How do we find acceleration? The definition for acceleration is a change, it's written like this, change in velocity, that means change in, divided by a change in time. And that means a change in velocity is velocity final, you always do final first, minus velocity initial, divided by, time final minus time initial, okay? You should recognize this equation from slope-intercept form in math. Your math equation looks like this, y equals mx plus b, and the m equals slope, which equals a change in y over a change in x, which is written as y2 minus y1 over x2 minus x1. That is the same as this, except for the y is v and the x is t. And if you look at the graph, the y-axis is v and the x-axis is t. So all we're doing to find the acceleration here is we're finding the slope. And the slope of this line is constant, so you can use any 2 points to find the slope. So let's look at let's choose a final velocity. And when you want to choose a final velocity, you don't want to use a point like this because the line doesn't go over the intersection, very closely. So you want to try and find a point that it just nails the intersection like really well. Like I would use this point here. We're going to use that point there, and another one. You want them to be kind of far apart. Ooh, that looks like a good one right there. Okay, but any 2 points on here will work. All right, so let's say our final velocity. Well, as time moves this way, the final is going to be the furthest this way. So our final velocity is 4. So we're going to say 4 because that's our final velocity, or our second point on the y, minus, what was the initial velocity? This is our initial point. The initial velocity was 8. Now we're going to do the time. What was time 2, right? Final time, right? That's this one. Time was 10 minus, what was the initial time? We'll go back to 8. The initial time was 5. So we have 4 minus 8, that gives us a negative 4. And we have 10 minus 5, that gives us a 5. So negative 4 divided by 5, I can't do that in my head, so let me get my calculator here. So 4 negative, whoops, come on baby, negative 4 divided by 5 equals 0.8. So the acceleration or the slope is negative 0.8. That's meters per second squared. Those are the units of acceleration. Now, why is it negative? Well, negative means that the object was slowing down. And if you look at the graph, is this a positive slope or a negative slope? It is a negative slope, so that is correct. Because it's a multiple choice question, you want to look for the multiple choice answer that is closest to this answer. Because of the nature of reading the graph, just because in our eyes it looks like it crosses immediately at 8 and 5 here, and at 4 and 10 here, it might not. It might be like 4.99, or I'm sorry, 4.009 or something like that, which could throw the final answer off a little bit. But as long as your multiple choice selection is close to this, you'll be good.